Are we rolling? Okay. This is going to be, this is 4-7 for Advanced Algebra 2, alright? We are going to solve systems using matrices. And if you think back to like 2 weeks ago, alright, we had solve by elimination and solve by substitution with a couple of lines. And then we introduced 3 planes back in chapter 3. And we had 3 planes with 3 variables with 3 equations. And you had to find the point in 3-dimensional space where they intersect. This is going to make things a little bit easier for you by using the calculator. Alright? Let me give you a system. I'm going to start out with 2 lines here. And my first line is 2x plus 3y equals -1. Okay? And my second line is x minus y equals 12. So I have 2 lines. Common sense might tell us that the 2 lines have different slopes. And because the slopes are different, I know that these lines intersect somewhere. Alright? I want to give you 2 ways that you are able to write this. First of all, I can write it as an xy coordinate because these lines will intersect at a point, x comma y. But in the form of a matrix, you can write your answer as an xy 2-by-1 matrix, which technically is really the same thing. And what you should say is the matrix xy is equal to whatever these 2 numbers are, say 5, 7, or whatever the answer might be. But in order to use a matrix, we have to turn our system into a set of matrices, and it is very, very simple. I have 2 matrices, 2 equations, so my first matrix is going to be a 2-by-2. And that 2-by-2 is the set of coefficients. In this case, 2, 3 in the top row, and 1 and -1 in the bottom row. Okay? Mr. Wilkes, I explained this to you a little bit a few days ago. What we have in the second matrix is just going to be my variables x, y. Alright, and I put them up and down like this, and I'll show you why. This is going to be equal to my constants, -1 and 12. -1 and 12. Okay? The reason it is set up this way is this. If I were to multiply these, what is the process for multiplying matrices? Row times column, right? So I would take the row and I would multiply it by the column. That is, the 2 would go on top of the x, and that would be 2 times x, which I have right there. And then the 3 would go on top of the y, and that would be 3 times y, which I have right there. And what do you do to those 2 values? You add them together, I have a plus, and it is equal to that very first number, which is why it's equal to -1. Second row, 1, -1 times xy is 1x plus -y, or 1x minus y, and it's equal to that second number. So now I have a set of matrices that represent my system. These matrices have names. This is called the coefficient matrix. Common sense. This is called the variable matrix. Even more common sense. And this is called my constant matrix. And I name these because your book says identify the coefficient matrix, identify the variable matrix, identify the constant matrix, and so on. Does that make sense?
Yes.
Now, how do I solve for x and y? Oh, well, I could use elimination, add them together, get a variable to eliminate, and back substitute, and it's really kind of obnoxious. Or I can get a variable by itself and resubstitute back in. You get a whole new equation. You got to use algebra to solve it. Matrices is a little bit easier. If I store this 2-by-2 in my calculator as A, and I store this 2-by-1 in my calculator as B, how can I get the variable matrix by itself? A inverse B. Does that ring a bell from yesterday? And A inverse B, if I were to write it like this, if I were to write A times x equals B, the reason is that I have to eliminate this coefficient matrix. That is, I would take A inverse of both sides, and I would take the A inverse of the right side. A inverse cancel. And that means my xy matrix, or my variable matrix, is now equal to A inverse B. And if you are good enough to memorize A inverse B,